Right there. Okay? You guys graph that? Laura, did you graph that? Graph look like that? Okay, so notice what you see here. In this region here, you can't tell the difference between the line and the function. In other words, the line is a good approximation to 1 plus sine x over this region here. Guys with me on that? Yeah? So the straight line is a good approximation to 1 plus x. Okay, so here is the actual mathematical way of writing that approximation. Get this down and then we'll talk a little bit more about it. Yes? I want you to fill in all these blanks here for the example that Stephanie just worked out. Okay, for the example that she just worked out. Okay, so someone help me fill this out. Okay, C equals 0. Because remember the point is 0, 1. And C is the x coordinate like it tells you right there. What's f sub c? 1. F prime of c? 1. And now if you start putting these values into this equation here, okay, you get that f star x equals fc, which is 1, plus f prime c, which is also 1, x minus 0, which gives you x plus 1, which is the equation Stephanie came up with. Okay, so this is a formula that gives you the linear approximation to a function. A linear approximation to a function. Okay, back in the old days, like, I don't know, 30, 20 years ago, this is a very common way of evaluating a function because a function can be very complicated, whereas a linear approximation is very easy to calculate, even by hand, without a calculator. So this is a fairly common technique of evaluating functions, particularly for engineering applications. Okay. All right. Moving on to what I'd sent you last night. Sent you an email on this last night. So those of you who printed this out, you're in good shape. Those who haven't will have to take it down right now. This wasn't the one. So this was the first of the two, okay? First of the two. So copy this down and then let's talk about it. Just so that you see what's going on here, this red line here is delta x times f prime c. Okay. The blue line here is f sub c. Actually, that's, yeah, it's true. And then the black line, that's this one here, is delta x, which is the same as this. All right, so you are given this function, okay? You're given that function, the blue one there. And you're given a point on it, okay? And the point is c, comma, f sub c, as you see here, okay? Then what you're asked to do is you're asked to move that point from there to there. And you move it by changing the x value from whatever it is, which is c, and add delta x to it. So your x value changes from there, it comes here, and then that point on the graph ends up being here. Okay? Well, this is the actual y value that you want of that point. What we're going to do is we're going to develop a method of giving you the y value for this point. Okay, can you guys see that in purple? Of that point. And we're going to say that the y value for that point is very close to the one that you really want, which is this one here, the y value of that point. Okay. So again, it's going to be an approximation. You guys got that down okay? All right. The next image will show you the calculations that go on, okay? And then I'll go over that too. So take this down and let give you a couple of minutes to get it done, and then let's go over it. To understand this calculation here, okay, dy equals f prime times dx. Does everybody agree that the slope of the tangent line is given by the tangent of that angle there? Okay, so slope of tangent equals f prime of x, and that is given by rise over run. So here's my rise. It's my rise. Here's my run. So my rise is dy. My run is delta x or dx, doesn't matter, okay? Notice that delta x and dx are the same thing, okay? Dy and delta y are not the same thing, okay? Delta y is the exact change, or the actual change right there in function value. And dy is an approximation to it. Okay, so my rise is dy, my run is dx, so delta x, same thing. And therefore, dy is equal to f prime of x dx if I cross multiply. That's where this equation comes from. Okay, all right? Everybody got this down? Okay. All right, got it. Okay. All right. One example, and then I'm done. Okay. Okay. You want to compare this to delta y. Delta y is the actual change, okay? So the way you do that is you know your x value is changing from 1 to 1.01. So you're going to do f of 1.01. And your original x value was 1. Okay? So can you go chug this on your calculator and come up with an answer for me, please? Taddy, got it?
Where did you get the 1.01 from? Yeah.
This plus this. Okay. Someone got me an answer on this? Yeah. 0.0201 or just 1? 0201? Okay. So if you compare, remember this is the exact, this is the approximate. Okay? Is that pretty close or what? Okay, so the approximation is a pretty good approximation for this function. Okay, it'll obviously depend on what dx is. If dx is going to be very large, then your approximation is going to be very poor. Okay, so remember what I told you when I was doing the sine graph. It was only within a certain range that the two are overlapping. Okay, within a certain range that the two are overlapping. You guys all right on this stuff? Okay, what I would suggest is that you start working on your homework. You've got like 9 problems for homework. You have questions, this is the time to get it because tomorrow I'm doing the second part of this.
How do we know how to find delta y?
Which one? This one here? Delta y is from the formula, it's going to be f of c plus delta x minus fc from this formula.